Welcome to The Explainer. Okay, let's dive straight into this. I want you to close your eyes for just a second and imagine a sweeping, cinematic wide shot. Picture a bustling global port right at dawn. The lighting is super dramatic, the air is just thick with anticipation, and these towering metal giants are bathed in the morning sun. What you're looking at isn't some crazy sci-fi movie set. It's the actual beating heart of global trade. Today, we are going to explore the breathtaking, larger-than-life world of cargo ships and the heavy machinery that quite literally keeps our planet running.
It really begs a massive question, doesn't it? How does the world actually move mountains across the sea? I mean, we all buy things, but rarely do we conceptualize the sheer cinematic scale and the hidden mechanical choreography required to move our global economy. Every single day, millions of tons of cargo are loaded, shifted, and sailed across the oceans. And to pull off a blockbuster production of this magnitude, you need a highly specialized cast of characters and, frankly, some incredibly heavy props.
Section 1. The Mechanics of Movement. Lifting the World. So first off, notice the incredible contrast between the equipment on the ship and the gear on the shore. Classic ships use derricks, which you might know as booms, and often they work in this fascinating mechanical ballet called a union purchase. Basically, two derricks are connected by a wire to a single hook. One derrick hangs over the jetty, the other hangs over the hatch, and together they seamlessly swing cargo up to 5 tons back and forth. Now, modern ships have mostly replaced those with faster, high-capacity hydraulic or electric cranes. But transition to the shore and the scale just absolutely explodes. Ashore, you've got these massive, rail-mounted gantry cranes towering over the pier. And right below them, straddle carriers and forklifts scurry around, picking up the cargo and seamlessly transferring it between the pier and the warehouse.
Now, it's fascinating to see how we move homogeneous dry bulk cargo. Think absolute mountains of grain or fertilizer. It's not boxed up. It flows almost like a continuous river. To discharge it, ships use massive grabs connected to gantry cranes that can literally bite out 10 to 20 tons of cargo at once. Or they use evacuators, which, get this, suck the grain right out of the hold. There's also the simple but totally ingenious screw conveyor. It spins a mechanical screw inside a cylinder to lift fertilizers and chemicals upwards. And once it's lifted, the cargo is dumped into a compartment and whisked away to storage on an endless conveyor belt.
Section 2. The Everyday Workhorses. General Cargo Ships.
First up in this crew is the tween-decker, which utilizes a brilliant piece of spatial engineering. It features a transverse partition, basically a second deck, sitting about 2/3 of the way up between the floor of the hold, called the tank tops, and the main deck. Why do this? Well, it's all about weight distribution. Heavy cargoes get stowed safely in the lower hold, right on the tank tops, while your lighter, high-volume cargoes are placed up on the tween deck. It perfectly keeps the heavy stuff from crushing the light stuff, allowing the ship to carry a highly organized mix of goods.
Next, we have the shelter deck vessels. Visually, they look a whole lot like tween-deckers because they also have 2 decks, but their origin story is a bit more, let's say, clever. The lower deck is actually the main weight-bearing deck, and the upper deck acts merely as a protective cover. But the real reason this design came into existence wasn't just structural, it was an architectural loophole. It was specifically designed to exploit tonnage regulations so it maximizes the ship's cargo capacity while legally minimizing the liabilities and taxes that are based on the ship's official tonnage. Kind of a sneaky design trick on the high seas, right?
Section 3. The Container Family. Masters of Geometry.
Okay, it's so helpful to use this visual analogy from our source material here. Cellular container vessels are built with internal cell guides that crisscross to form exact rectangular spaces. The standard containers, which are known as TEUs, or 20-foot equivalent units, and FEUs, 40-foot equivalent units, slide perfectly into these slots, tier upon tier. It's, as the quote goes, rather like ice cubes in an ice tray. It is an absolute marvel of efficiency. About 60% of the containers are stacked securely under the deck in these guides, and the remaining 40% are stacked right on top of the deck, locked together using heavy-duty twist locks.
But think about this for a second. How on earth do you find one specific container out of thousands? Well, the secret is this brilliant 3D coordinate system acting as the ship's address book. It's called the bay, row, tier system. A bay is the section of the ship's length. A row is the position across the ship's width. And a tier is how deep or high it is stacked vertically. So if a longshoreman is looking for a specific box, they just look up its coordinates. Let's say 14, 04, 10. That simply means it's in bay 14, row 4, tier Tier 10. It pinpoints the exact location of a single metal box in a sea of thousands.
And looking at the explosive evolution of these vessels, the massive jump in scale is wild. The first generation carried less than 1,000 containers. But as global trade absolutely exploded, the ships had to keep up. We pushed through the second, third, fourth, and fifth generations, constantly scaling up the capacity until we hit the jaw-dropping sixth generation, the post-Panamax giants. These deep-sea leviathans carry well over 6,000 TEUs. Actually, some are so massive, at 6,500 TEUs and above, they can only call on a select few ports worldwide that actually have the deep water and giantless short infrastructure required to handle them.
Section 4. The Heavy Lifters. Ships carrying ships.
Now this is where the sheer mechanical muscle is just astounding. Let's talk about barge-carrying vessels. These ships carry massive preloaded barges. First up, the Lash, lighter aboard ship. It carries 80 barges, with each holding 400 tons of cargo. To load them, it uses a gargantuan 510-ton gantry crane mounted right on the stern. Then there's the Seabee, which handles 38 massive 1,000-ton barges, lifting them straight up using heavy-duty elevators at the back of the ship. And the Bako? Oh man, it literally swallows them whole. It opens giant doors at its bow, floods its internal hold, floats a dozen barges directly inside, closes the doors, and pumps the water out. It's a spectacular piece of engineering.
And if that wasn't dramatic enough, let's see how this builds with the low-sly, or lift-on, lift-off vessels. These are built for indivisible heavy loads, often greater than 50 tons. While some use onboard cranes capable of lifting up to 1,000 tons, the most spectacular variation is for sure the semi-submersible. Just picture this. The ship intentionally floods its own ballast tanks to sink itself below the waterline. It then slides smoothly underneath a massive piece of cargo, pumps the water back out, and slowly rises from the sea, scooping the cargo right up on its back. It is a stunning visual to imagine.
Section 5. The Montage. Highly Specialized Titans. Starting with the bulk and grain specialists, you have your standard bulkers, these single-deck, unobstructed giants carrying massive quantities of bulk commodities. But then you have Lakers, which are specifically engineered to carry grain. And grain is tricky, you guys. If it shifts during a voyage, the ship can completely capsize. So Lakers are built with hoppered, or angled, lower corners in their holds. This ingenious geometry actively prevents the grain from shifting around and helps the cargo trim, or level, itself during the voyage. Moving over to the rugged industrial haulers, ore carriers are super compact and immensely strengthened to carry incredibly dense minerals. Loggers have these perfectly squarish holds, allowing massive tree trunks to be stacked horizontally without snagging on any of the ship's gear. And then there are the cement carriers. Cement powder is notoriously messy and terrible for the air. So, to solve this huge pollution problem, these ships are loaded pneumatically. They use specialized holes in the hatch covers, literally pumping clean cement in through one hole while safely venting air and dust out through another. It's a brilliant, completely dust-free solution. Let's pivot to a totally different type of movement. ROO/RO vessels. Roll on, roll off. Instead of lifting cargo with cranes, you just drive it on board. These ships feature super sleek slewing ramps that rotate in an arc to smoothly dock with the quay. Inside, they are basically multi-story floating parking garages connected by internal ramps and lanes. And to truly understand the mind-boggling scale of these floating garages, just look at this number, 6,000. Pure car carriers, which are a highly specialized type of RO/RO, can transport up to an astonishing 6,000 vehicles on a single voyage. They are just driven onto the ship, lashed down tightly to the decks for the entire ocean crossing, and then simply unlashed and driven off at their destination.
Now what's a blockbuster without a cool shapeshifter? Meet the ultimate transformers, combination carriers, or ELBOs. That stands for Ore Bulk Oil Carriers. These vessels are incredibly versatile. With their strengthened tank tops, double skins, and gas-tight steel hatch covers, they can carry dry, heavy iron ore on one voyage and then fill those exact same giant compartments with liquid oil on the return trip. However, there is a major catch. Switching between dry rocks and liquid crude makes them notoriously difficult, time-consuming, and really expensive to clean.
Finally, we finish our cast introductions with the immaculate edible oil carriers. Unlike those rugged OBOs, these are pristine parcel tankers carrying the oils we actually consume. Because purity is absolutely vital, their tank walls are coated with special chemicals to prevent any corrosion or contamination, which makes them incredibly easy to clean between cargoes.
They even use totally separated pump and pipeline systems so they can safely carry entirely different parcels of edible oils on the same ship without them ever mixing.
Which brings us to our final thought. Think about it. The clothes you're wearing right now, the food you eat, the device you are using to watch this very explainer, which of these cinematic giants carried it to you? Was it swung by a Union-purchased derrick? Was it stacked high in the Bayrow tier of a massive post-Panamax? Or maybe driven off the slewing ramp of a row/row? Literally everything around us was once part of this epic, mechanical, maritime choreography. I hope this explainer changed the way you see the hidden world that moves our lives. Thanks so much for learning with me today, and I'll catch you in the next explainer.